Okay, today we are going to cover the last two pieces in Chapter 1, which is sections 5 and 6. So section 5 is talking about bias. Remember, you do have your example sheet and your terminology sheet to write things down on as we go through. So we are talking about three different sources that we might see bias through to begin with. Alright, the first one is sampling bias. So this happens because of how you chose your sample. You favored one population over another. A situation that might result in this would be undercoverage. Maybe you are looking at a community where 30% of the population is Hispanic, but in your sample you only have 5% Hispanic. Or maybe your sample has 70% Hispanic. And so that sample does not accurately reflect the population itself. So your bias is really just when your results aren't representative of the entire population. And that can be because of how you chose your sample. The second option is non-response. Okay, you send out a survey. I put a survey on Classroom and only a third of you answer it. I can't expect that the responses I got accurately depict the opinions of everybody in the class. Those that didn't respond might have different opinions from those who do. So non-response happens when you just have people that don't respond and their opinions might be different. You might have to pause this to write down some of your definitions. Please do so. The third type is response. You picked a good sample. People are responding to you, but their responses actually don't reflect their true feelings. And so this can happen a couple different ways. The first is interviewer error. You have to make sure that you have a good interviewer and that the questions they're answering, they would feel comfortable giving their answers to the interviewer. For instance, if I said, I want to decide if you guys like my teaching technique. And so I go up to each of you and ask, do you like how I teach? Yes or no? You are probably going to be less likely to tell me no because I'm your teacher, I'm giving you a grade, and I'm standing in front of you asking you what you think. So even if I had a good sample, the error was on me because you're not going to tell me your true feelings in that scenario. Second is misrepresented answers. Okay, so I might give a survey and ask, how many hours a week do you study? And you answer that, but you might inflate your answer a little bit. I studied for 20 minutes, but that's close enough. I'm going to say I studied for an hour for that test. So you give an answer, but it is not accurate. Number 3, wording of questions. Sometimes if your questions are confusing, if people don't understand what it's asking, then they might give you the wrong answer. It doesn't truly reflect their feelings. Or sometimes if you use strong language, then people are less likely to answer it correctly. So for example, if I said, do you think we should mandate masks in our school? Versus, do you think we should ask everyone to wear a mask in our school? The word mandate, that's a strong word. It's kind of like forbid. People don't like that word. So if I want to mandate something, people are going to be like, no, that's a bad idea. But if I say, should we ask people to wear masks in our school? You'll be like, oh, that's not so bad. So it might just be the words you use. Do they put a positive or a negative thought in people's heads? And the final thing, the order of the questions or the words. You have to watch. Sometimes if you have a long survey, people answer the first few questions and then they just start filling in A for everything. So if you have a really important question, you want to make sure you have it sooner. You might ask one question that makes them think along different lines and changes how they respond to questions later on. So the ordering can make a difference. All right, so the 3 types of bias: sampling, response, and non-response. When we talk about the different errors that we see, there are 2 types of that: sampling and non-sampling. A non-sampling error isn't that the problem was the group you chose, it happens because of how you obtain and record your information. Sampling error is a result of the sample you chose. So it's because you had a poor sample to begin with that you got bad results. Non-sampling error might be, I was recording people's answers and I wrote down the wrong thing. Or I had some response bias in the answers that I got. And so that changed the data, and that gave me a non-sampling error. Okay, that is the end of section 5. Now we're going to start with section 6. Okay, so the final thing in this chapter is talking about designing an experiment. And unfortunately, we do start out with a lot of definitions again, so you may need to pause your video while you write some of these down. The first thing we're talking about is an experiment. An experiment is some type of study that's conducted to determine the effect of varying one or more explanatory variables or factors, and to see what effect that has on the response. So an experiment is a controlled study to determine the effect of the explanatory variables on the response variables. The experimental unit is your subject. It's just the person or object that you're applying your treatment to. The control group is your baseline treatment, and you're using them to compare to everyone else. And a placebo, that you've probably heard of this, it's just something that looks, smells, or tastes like the experimental medication, but it's not. It's like a fake, so people don't know if they're getting the real thing or not. Again, pause this to write down your definitions. The 2 types of experiments that we might have here, you can have a single or a double-blind experiment. In a single-blind experiment, there's just one person that's blind to it. The subject doesn't know which treatment they are receiving. Double-blind, there are 2 people that don't know. Neither the subject nor the researcher knows which treatment the person is getting. Alright, so let's look at an example. The English department of a community college is considering adopting an online version of the freshman English course. To compare the new online course to the traditional, a faculty member randomly splits a section of her course. Half the students receive the traditional and the other half is given an online. At the end of the semester, both groups will be given a test to determine who performed better. So the experimental units, those are the people that are the subjects in this. Those are just your students in the class. The population for which this study applies. Well, in this case, she was able to look at her whole class. Okay, so the population we are concerned about would be all the freshmen taking an English course. Because we're using one professor's class to do this, but it would apply to all the English students. The treatments, the thing we are manipulating here is traditional versus online. Response, the thing we are measuring is how they do on their test, their exam score. Why can't this be done with blinding? So blinding is when you don't know what treatment you're getting, but a student clearly knows if they are in person or online. So there's no way to do that without them knowing. Okay, so we've talked about or defined two types of experiments, single and double blind. The third type of experiment that we could have is completely randomized. So each person is just randomly assigned a treatment. I use a random number generator. I have treatments 1, 2, or 3, and for each person I randomly generate a 1, 2, or 3. I randomly pick which treatment they get. So let's look at an example. An engineer wants to know whether the level of octane in gasoline affects the gas mileage of an automobile. So, actually, I think I'm going to change this example a little bit. I'm going to ask you guys a series of questions here. Okay, so here are the questions I want to answer. What is the problem to be solved? What am I trying to figure out here? And in this situation, the engineer wants to know if level of octane affects the gas mileage. Okay, the factors, those are like the explanatory variables, okay, not the response. The response variable here, the thing we're measuring, is the gas mileage. Explanatory is the thing you can control. So we have to be careful. We have to think about all the things that could impact the octane level, or excuse me, the gas mileage. Obviously, we're concerned with the octane level, but there are other factors that you definitely want to control, because we know there's more than just that goes into the gas mileage. You're also going to have to consider like engine size, driving style, road conditions, temperature. All of these things can impact the gas mileage. So you'll have to control as many of them as you can. Otherwise, you'll have some confounding in your results. You won't know what's caused by the octane level and what's caused by a difference in driving style. So how should the automobiles be chosen? I can't just go out and say, okay, I'm going to test my minivan versus my husband's truck, and I'll put different octane gas in each of them and see who gets better mileage. That's not going to work. So you have to have the same make, model, year. You have to have the same vehicle that you're testing. You want to try to control as much as you can. So you're talking same engine size, driving conditions. Ideally, you would try to drive them on at times when the temperature, outdoor temperature, is the same, but that's kind of uncontrolled. We don't have a lot of choice in that. We can't make two perfectly identical weather days, but getting the situation as similar as possible. And so then how could we conduct an experiment? Okay, so one of your homework problems is going to ask you to draw a picture to design for an experiment they described to you. So I'm just going to draw a picture here. We can take a random, let's say 12 cars that meet these requirements. And then let's say I have 3 different levels of octane. So I need to take my 12 cars and divide them into 3 groups to test the 3 different levels. So you can randomly pick which one goes to which. And then each of those gets an octane level. And they go out and drive, and then at the end we compare. We were worried about mileage, so your miles per gallon. So you can describe an experiment in words, or you can use kind of a picture like this to help describe the scenario. And that would allow us to see if there is in fact a difference among them. The next type of experiment that we might see is a matched pairs design. So in this scenario, you pair them up, your experimental units or your subjects, so that they're somehow related. It might be a before and after. I want to see if this new exercise program has an impact on your BMI. So I take your BMI before and after the experiment. That's matched pairs. I pair that data up. So looking at an example here. Xylitol has proven effective in preventing dental cavities when included in food or gum. A total of 75 Peruvian children were given milk with and without xylitol and were asked to evaluate the taste of each. Researchers measured the children's ratings of the two types of milk. So my response variable here, the thing we are measuring, that's how they rate their milk, the rating of the milk. Okay, think about some of the factors in the study, which are controlled and which one is manipulated. So the factors in my study, the thing we're manipulating is if the milk has xylitol or not. Other factors that are more controlled. We took a group of 75 children, but if we want to have this consistent results, we need to make sure we are looking at things like age, maybe gender. Are males more likely to like this drink than females? Or, is a 2-year-old more likely to like the milk than a 10-year-old? So we would have to control for those things. The treatment is which type of milk they get. So there are 2 treatments in this. You either have plain milk or you have milk with the xylitol in it. Experimental design. Okay, in this situation, the children don't know which type of milk they're drinking, but we can assume that the researcher does. Oh, excuse me. I was thinking that I had said you're just comparing if the children like which one they like better. But it's the same child that drinks both types of milk, excuse me. So one child, they taste both types of milk. So this is matched pairs. The experimental units would be the 75 children. Why would it be a good idea to randomly assign whether they drink the milk with or without the xylitol first? You have to control as much as you can. If we give all the kids plain milk first and then they drink the milk with xylitol after that, they might think, oh, this tastes different. That's funny. I don't like it. If they give it to them, every child drinks the xylitol first, they may take the first sip and think, oh, that's fine. And then they get the second drink, the plain milk, and they think, oh, wow, this is even better. So you want to alternate who gets what first, just to prevent bias. Removes the effect of order on the results. Do you think it would be a good idea to double blind this experiment? Would it be a good idea for the researcher to not know which one they're getting first? And that might be. Sorry about that. If the researcher knows that they're drinking the milk with xylitol, they might have a different expression on their face, or they might be extra encouraging. You really liked that milk, didn't you? And say something that might influence the results. So it would probably be a good idea that neither the child nor the researcher knew which type of milk they were getting. right, last types of experiments. Blocking is when you group together similar units and then randomly assign within each group to a treatment. So I take different geographic regions. So each geographic region would be a block. And then I take people within that block and randomly assign them a treatment. The randomized part, if you are randomly giving the treatment, that makes it a randomized block design. You could also be very systematic about it and be like, okay, this block is going to get this treatment, and take away that randomization. So last example, I apologize. I know this is a longer video. I'll make up for it tomorrow. I'll do a short lesson tomorrow. Recall the English department is considering adopting an online version of the freshman English course. After some deliberation, the English department thinks that there may be a difference in the performance of the men and women in the traditional and online courses. So how could we fix that? We want to design an experiment that could be used to measure the difference in the performance, but take into account gender. So we still have to have students in each type of course, but I don't want more men to be taking it online than women. So you would essentially just need to assign half the men and half the women to each course. So you want to control as many variables as you can so that the results you get are actually caused by the thing you're varying, the online versus in person. Okay, so homework. We have 2 sections here. So you are just going to add this to the first 4 sections that you already have. So you'll turn in all of your chapter 1 work at once. And I apologize, I know today was a longer day, so tomorrow will be shorter to kind of help balance that out for you. So this, you will just wait, and then Monday or Tuesday, whichever day you are coming to school, you will give me all of your chapter 1 homework at once. So please keep it nice and organized, label which page it is, so when I look through it, I know what I'm looking at.